Hey everyone, welcome to Mr. Winter's AP Chemistry videos. I'm Mr. Winter. Today we're going to be talking about percent composition. Today, if you guys could have your graphing calculators out or just a regular four-function calculator, your periodic table, pen, pencil, your graphic organizer, which is down below, we can go ahead and get started. So without further ado, here we go, percent composition. So first off, before we jump into this, I want to make sure everyone's clear with what a pure substance is. A pure substance is going to be a sample of matter that has a definite composition, a consistent and constant composition. When we're looking at pure substances, we can talk about pure water, which is H2O. Pure water, right, has the formula of one oxygen bonded to two hydrogens, right? This would be a molecule of water. We could have a pure sample of sodium chloride, which is NaCl. For every one Na, there's one Cl. So both of these here are examples of pure substances as long as they are by themselves. Regardless of the source of the sample of matter, it has the same chemical and physical properties as any other source or any other sample of that pure substance. A pure sample of H2O is going to have the same properties as another sample of pure H2O. So with that being said, we can kind of jump in and define the law of definite proportions. The law of definite proportions is also sometimes called the law of constant composition, and it really just says that the ratio of masses of a constituent elements in any pure substance is going to be the same, meaning that the ratio of those elements is constant. So once again, this is going back to like really just defining what a pure substance is. And that means that the percent composition of any element within a compound is the same. So what is percent composition? The percent composition is going to be the percent by mass of a constituent element in a pure substance. Now there's an unofficial formula that I like to give my students when we're looking at percent composition. Percent composition specifically is, so percent composition of an element is equal to the mass, the molar mass of that element in a compound. So sometimes there's more than one element in the compound, more of one of that type of that element. So we're going to multiply this by a whole number. So if it's H2O, there are two hydrogens for every hydrogen. And you're going to divide this by the molar mass of the compound. And because it's a percentage, we multiply by 100%. So yeah, every once in a while, you'll literally just be asked to take a percentage in the chemistry class, and using this unofficial formula here, you basically take part over whole. So how much of your compound is hydrogen? How much of it is oxygen? Take that mass and divide it by the total mass of the substance of the compound. If you're dealing with just molar masses, it's pretty much just that. Now, let's go ahead and check out a type of problem that you could see, and hopefully that you'll be kind of comfortable with based off of the formula we just did. We want to find the mass percent of the constituent elements in xenon tetrafluoride. That is the formula XeF4. So let's go ahead and make our lives easier. Go ahead and grab your periodic tables. Let's find the molar mass of fluorine and the molar mass of xenon Xe. If you look on your periodic table, fluorine's roughly 19.00 grams per mole. Xenon here is 131.29 grams per mole. So there's the molar mass of each of these here. And with our formula, we're going to need the molar mass of xenon tetrafluoride, so it's XeF4. Hopefully you guys remember to do this. There's one Xe and four fluorines here. So 131.29 plus 4 times 19.00. And this gets us the molar mass of 207.29 grams per mole. So we want to find the mass percent of the constituent elements. The word constituent just means the elements that make this up. So we're going to find the percent composition for fluorine and the percent composition for xenon. So let's go ahead and do fluorine first. There are 4 fluorine atoms. Each of those fluorine atoms has a molar mass of 19. We're going to divide this by the molar mass of the entire compound, which is 207.29, and multiply this by 100%. We find that the percent composition for fluorine, now's the time, remember to punch this into your calculators here. Make sure you get the same answer as me, 36.67%. Now, a couple things that I want to point out. You can do this again for xenon. You can just use the same formula where it's going to be 1 times 131.29 divided by 207.29, and that will get you the percent composition. But I want to remind everyone that percentages add up to 100. So the percent composition for xenon, if I just have two elements, will equal 100 minus 36.67, getting us, what would that be, 63.33%. So that's kind of a fun one because of the threes. Thanks so much, and I hope you guys have a great day.